All right, demo F2. So this is Luna's problem. Luna's allocated 10 galleons, which she can spend on either pumpkin pasties at a price of 2 galleons per pasty, or she can spend her 10 galleons on chocolate frogs at a cost of 2 galleons per frog. Okay, and then we're told sort of in the beginning here that there's going to be an improved harvesting technique for growing cocoa. So eventually the price of chocolate frogs will be cut in half, which happens right before the holiday season, which is going to be nice. All right, so the first question is to draw Luna's budget constraint before the harvesting technology. So here we're given on the vertical axis, we have frogs, and the horizontal axis we have pasties. And so originally we have 10 galleons, which Luna is dividing between the two goods at a price of 2. So our intercepts are going to be 10 divided by 2. So we have 5 and we have 5. And then we just draw a straight line between them, representing the constant marginal rate of transformation. All right, so then the second question is to show the effect of the new harvesting technique on Luna's budget constraint using the same graph. So here, what we're saying is with the new harvesting technique, the price of chocolate frogs gets cut in half. So the new price of chocolate frogs is 1 galleon. So the vertical intercept now goes from 5, because it's 10 divided by 2, to 10, which is 10 divided by 1, the new price. And then we just connect this to the original horizontal intercept, which hasn't changed. Nothing about the price or income for buying pumpkin pasties has changed. All that's changed is the vertical intercept, and then every combination of pasties and chocolates that contains some number of chocolate frogs. So there's one point on the graph when Luna is spending all of her money on pumpkin pasties. That's the only point that's not changed between the two budgets. Okay. So we're asked in question 3 to use a graph of Luna's indifference curve to show the effect of the new harvesting technology on Luna's optimal consumption bundle. And we're told to assume that the substitution effects outweigh the income effects for pumpkin pasties. All right, so we're going to show the new indifference curve as I2, and we're going to show that the second quantity of pumpkin pasties, P2, is lower than P1. All right, so to do this, we first solve Luna's consumption problem. So first we start at I1. So this is the original budget, and we find the point of tangency, so where the marginal rate of substitution is equal to the marginal rate of transformation. That's where we can do no better using that budget constraint. So we've climbed the mountain as high as we can, and we've arrived at P1 and some quantity of F. So we could call this F1 if we wanted to. Then the price of chocolate frogs goes down, meaning we can afford more chocolate frogs than we could before. What we're told is that the substitution effect will outweigh the income effect. So the income effect tells us that as we increase what's available to us, it's as if we've increased our income. So the price goes down, and essentially more becomes available for us to buy. More becomes affordable. So that should tell us that the quantity, that on its own would tell us that the quantity of pumpkin pasties would go up. But we're also told that the substitution effect outweighs the income effect. The substitution effect tells us that the price of chocolate frogs has now gotten relatively better than the price of pumpkin pasties. We've lowered the price of chocolate frogs without affecting the price of pumpkin pasties. So frogs have become a better deal relative to what they were before. So frogs have become a better deal. We're going to switch towards buying more frogs from buying more pasties. And what this means is that we would see a shift towards chocolate frogs away from pasties. And what we're told is that this substitution effect, the fact that chocolate frogs have become a relatively better deal, we're told that dominates the income effect, the effect of lower prices, meaning more is affordable to us, which would suggest we would see more pasties. So we get these two competing forces. We're told that the substitution effect, the one coming from the relatively better price of frogs, that dominates. So what we see is a decrease in the quantity of pumpkin pasties. Okay, so that is question 3. Question 4 is about income. So we're given a holiday tax, which, this is really a terrible move. If you ever become a policymaker, don't do this. This is like a Scrooge type move. So in a shockingly tone-deaf move with questionable intents, the Ministry of Magic imposed a holiday tax. So maybe they're like trying to reframe it as something positive by putting holiday in the name. Which essentially, we're going to take 2 galleons away from everyone right before the holidays. So we're asked to use a graph to discuss the effect of this 2 galleon tax on Luna. Okay, so we have our original budget, or our post technology budget, and what we're doing is simply just shifting in the budget constraint. So we go from an income of 10 to an income of 8, and Luna can make, sorry, this is not a PPF, she can afford, on the horizontal intercept, 4, where she could afford 5 before, and the same 8 against 10. And if we go back to the original question here, we're told that both of these are normal goods. So we should see a decrease in the quantity demanded as income goes down. And that's exactly how we've drawn this. So at this new budget, we have this point of tangency on a lower indifference curve, which shifts, I guess that should say P, shifts the quantity of pasties and the quantity of chocolates in. Okay, and then we write a little conclusion here. We're asked to discuss this, so we'll write a little conclusion. This tax lowers income, so we see this shift in the budget, lowering our indifference and lowering both quantities, because we know they are normal goods. All right, so we'll leave this here.